Hello everyone. Welcome back to my course Aerospace Engineering, Complete Drone Guide. In this video, we will talk about understanding drone types from multirotor to FPV. Also, I will be thankful if you give me feedback about this course to make it better and more useful for you. Please write down your thoughts in the comment section or reach out to me via the email provided in my profile. Types of drones and UAVs. In today's world, drones have become an increasingly common presence across many industries. They are used for delivering packages, inspecting infrastructure, capturing cinematic footage, and performing a wide range of other tasks. As their usage continues to expand, it becomes important to understand how to identify and differentiate between the various types of drones you may encounter. This section provides a comprehensive guide to help you clearly understand the different classifications of drones and unmanned aerial systems. Drone definitions, UAV, UAS, and RPAS. The term drone is commonly used in everyday language, but it has a specific definition. According to the Merriam-Webster dictionary, a drone is an unmanned aircraft or ship guided by remote control or onboard computers. This definition is essentially identical to that of an unmanned aerial vehicle, UAV, and the two terms are often used interchangeably. The word unmanned simply means that there is no pilot physically on board the aircraft. It does not necessarily mean that no humans are involved at all, since many drones are controlled remotely by operators on the ground. It is also important to note that passenger-carrying drones are already being developed, which adds complexity to the term unmanned. This becomes even more nuanced when discussing emerging technologies such as electric vertical takeoff and landing aircraft, which will be covered later. While drone and UAV typically refer only to the aircraft itself, there are broader terms that include the entire system required for operation. One such term is Unmanned Aerial System, UAS, which refers to the aircraft along with all associated components needed for it to function. This includes control systems, communication links, and supporting equipment. Another important term is Remotely Piloted Aircraft System, RPAS. This definition is more detailed and includes the aircraft, the remote pilot stations, communication systems, and any additional components specified in its design. The key distinction between UAS and RPAS, according to the International Civil Aviation Organization, ICAO, lies in how they operate within airspace. UAS typically require special accommodations and must remain separate from other aircraft, while RPAS are designed to operate alongside manned aircraft in shared airspace. From a technical perspective, RPAS are always controlled from a remote pilot station, whereas UAS may be operated from either a remote pilot station or a ground control station. Fixed wing, rotary wing, and powered lift drones. Drones, like traditional aircraft, can be classified based on how they generate lift. This classification divides them into three main categories: fixed wing, rotary wing, and powered lift drones. Fixed wing drones. Fixed wing drones are characterized by wings that remain stationary and are attached rigidly to the body of the aircraft. Although control surfaces such as ailerons and rudders may move to control direction and stability, the wings themselves do not change position. These drones generate lift through forward motion, using the aerodynamic shape of their wings. Some advanced designs incorporate vertical takeoff and landing capabilities by using additional rotors. These allow the drone to take off and land without a runway, while still benefiting from the efficiency of fixed-wing flight once airborne. One of the main advantages of fixed-wing drones is their ability to remain in the air for extended periods. Their aerodynamic efficiency allows them to cover large distances using relatively little energy, making them ideal for applications such as surveillance, mapping, and environmental monitoring. However, these drones also present challenges. They typically require more space for takeoff and landing, especially if they do not have vertical takeoff capabilities. Additionally, they cannot hover in place, and their operation often requires more training and experience compared to other drone types. Rotary wing drones. Rotary wing drones generate lift using rotating blades that push air downward. This category includes helicopters and multicopters, all of which are capable of vertical takeoff and landing. The number of rotors can vary widely, from a single rotor in helicopter style drones to multiple rotors in multicopters. These drones are especially popular due to their ability to hover in place, making them extremely versatile for tasks such as aerial photography, inspections, and surveillance. They are generally easier for beginners to operate and are widely available at relatively low cost, particularly in smaller models. The main limitation of rotary wing drones is their energy consumption. Maintaining lift requires continuous power, which significantly reduces flight time compared to fixed-wing drones. As a result, their range and endurance are more limited. Powered lift drones. Powered lift drones combine features of both fixed-wing and rotary wing designs. They use rotors to achieve vertical takeoff and landing, then transition to forward flight where lift is generated aerodynamically by wings. This hybrid approach allows powered lift drones to operate in confined spaces like rotary drones, while also achieving the efficiency and range of fixed-wing aircraft. There are several variations of this design, including tilt-rotor and tilt-wing configurations. In tilt-rotor systems, the rotors themselves rotate to shift from vertical to horizontal thrust. In tilt-wing systems, the entire wing rotates along with the rotors during the transition. Both designs are sometimes referred to as convertiplanes because they change configuration during flight. Another type uses separate sets of rotors for vertical and horizontal flight. In this case, one set is dedicated to takeoff and landing, while the other is used for forward propulsion. Despite their advantages, powered lift drones are complex to design and operate. Ensuring stability during the transition between flight modes is particularly challenging, which is why these drones are less common. However, when successfully implemented, they offer exceptional versatility. Power sources: electric, gas, hybrid, and emerging technologies. The way a drone is powered has a significant impact on its performance, endurance, and application. Several power sources are currently used or being developed in the industry. Electric and battery-powered drones. Most modern drones, especially rotary wing models, are powered by lithium-ion polymer batteries. These batteries are lightweight, rechargeable, and well-suited for drone design. They are currently the most widely used power source in the industry. Solar energy is another form of electric power that has been explored. By placing solar cells on the surface of a drone, it is possible to generate electricity during flight. This has the potential to greatly extend flight duration, particularly for fixed-wing drones that offer sufficient surface area for solar panels. However, solar-powered drones are still limited in application due to design constraints. Gas-powered drones. Gas-powered drones use internal combustion engines and are capable of much longer flight times compared to battery-powered models. This is because fuel has a significantly higher energy density than batteries. These drones are commonly used for long-distance missions and are often designed with fixed wing configurations to maximize efficiency. They can operate for many hours or even days, making them suitable for applications such as large-scale surveillance and data collection. However, gas-powered drones tend to be heavier, noisier, and more complex to operate. They also require fuel management and engine maintenance, which adds to their operational complexity. Hybrid-powered drones. Hybrid drones combine two power sources, such as battery and gas or battery and solar. This allows them to take advantage of the strengths of each system. For example, a drone may use battery power for vertical takeoff and landing, then switch to a fuel-powered engine for efficient forward flight. These drones offer impressive performance and extended range, making them highly effective for demanding missions. They are becoming increasingly important as the industry seeks to overcome the limitations of single power sources. Hydrogen and laser charging drones. Hydrogen fuel cells represent a promising alternative energy source. They provide high energy density and produce clean emissions, making them environmentally friendly. Hydrogen-powered drones are already being developed for long-endurance missions. Another emerging technology is laser charging, where drones receive power from a ground-based laser while in flight. This allows them to remain airborne indefinitely as long as the connection is maintained. While still experimental, this technology demonstrates the potential for continuous drone operation. Types of drones. After understanding how drones are classified, it is helpful to look at some of the most common types currently in use. Multirotor drones, quadcopters, hexacopters, and octocopters. Multirotor drones are the most recognizable type, featuring multiple arms and high-speed propellers. They are named based on the number of rotors they have, with quadcopters having 4, hexacopters having 6, and octocopters having 8. These drones can be configured in different ways, including single rotor arrangements or coaxial setups where two rotors share the same axis. They are widely used for both recreational and professional purposes. Control methods vary as well. Some drones are operated using visual line of sight, where the pilot maintains direct visual contact with the drone. Others use first-person view systems, where the pilot navigates using a live video feed from onboard cameras. Helicopter drones. Helicopter drones operate similarly to traditional helicopters, using a main rotor for lift and a tail rotor to counteract torque. They can take off and land vertically and are capable of operating in confined spaces. Many helicopter drones are powered by gas engines, particularly in larger models, although electric versions also exist. These drones are increasingly being used in applications where human involvement would be risky, such as disaster response and search and rescue operations. Their ability to carry heavy payloads and operate in challenging conditions makes them particularly valuable for industrial and emergency use. eVTOL aircraft. Electric vertical takeoff and landing aircraft represent a rapidly growing segment of the drone industry. These vehicles are designed to transport people or cargo, particularly in urban environments. They have the potential to reduce traffic congestion and emissions by providing an alternative mode of transportation. Many companies are actively developing eVTOL aircraft for use as air taxis, aiming to make urban air mobility a reality. These aircraft can be fully electric or hybrid, and may be operated manually, remotely, or autonomously. Their flexibility and potential for integration into everyday transportation systems make them a key focus of current innovation. High-altitude long-endurance HAIL drones. High-altitude long-endurance HAIL drones are designed for missions that require flying at very high altitudes for extended periods. These drones can operate above 60,000 feet and remain airborne for days, months, or even longer. They are often used for military surveillance and reconnaissance, but they also have applications in telecommunications and weather monitoring. Some HAIL drones function as pseudo-satellites, providing services typically associated with space-based systems. Autonomous drones. Autonomous drones represent the next stage of development in the industry. These drones use advanced sensors and artificial intelligence to navigate and make decisions without constant human control. By analyzing their environment in real time, they can avoid obstacles, adjust their flight paths, and complete missions independently. This makes them highly effective for tasks such as inspections, mapping, and search and rescue operations. As automation technology continues to advance, autonomous drones are expected to play an increasingly important role across many sectors. What are FPV drones? FPV drones provide one of the most immersive flying experiences available in the world of unmanned aerial vehicles. The term FPV stands for first-person view, and it refers to a method of piloting where the operator sees exactly what the drone sees in real time. Instead of controlling the drone from a ground-based perspective, the pilot experiences flight through the drone's onboard camera, almost as if they are sitting inside the aircraft itself. This approach is what makes FPV drones fundamentally different from traditional drones. In conventional drone flying, the pilot typically watches the drone from the ground, or uses a screen that still represents an external viewpoint. With FPV, however, the entire experience shifts to the drone's perspective, creating what can be described as a drone's eye view. This change transforms flying into a much more engaging and realistic experience. Despite this difference in operation, FPV drones and traditional drones are quite similar in terms of their physical design. Both often include onboard cameras, and many standard drones can be adapted for FPV use if the pilot chooses. Similarly, FPV drones can be flown without relying on the camera feed if the user prefers a more traditional control style. Ultimately, the distinction lies more in how the drone is operated than in how it is built. How FPV drones work. FPV drones function in a way that is very similar to conventional drones, with one key addition that defines the entire experience. Each FPV drone is equipped with an onboard camera that continuously captures video during flight. This video feed is transmitted in real time to a device used by the pilot, such as FPV goggles, a headset, a smartphone, or another type of display. The transmission system is designed to deliver a live stream with minimal delay, allowing the pilot to react quickly to changes in the environment. This low latency is essential because even a slight delay between the drone's movement and the visual feedback can make precise control difficult. The combination of real-time video and responsive controls allows the pilot to navigate complex environments as if they were physically present inside the drone. Benefits of flying an FPV drone. One of the most notable advantages of FPV drones is the level of immersion they provide. The ability to see directly from the drone's perspective creates a highly engaging experience that feels far more advanced than traditional drone flying. This immersive quality is often what attracts people to FPV in the first place. Another important benefit is the increased precision and control. Because the pilot receives immediate visual feedback from the drone's viewpoint, they can make faster and more accurate adjustments. This is particularly useful when navigating tight spaces or performing complex UN movements, where situational awareness is critical. FPV drones are also highly valued in the field of aerial photography and videography. Viewing the environment from the drone's perspective allows pilots to capture unique angles and dynamic footage that would be difficult to achieve using standard methods. This capability has made FPV drones popular among content creators looking to produce visually striking material. However, these advantages come with certain challenges. Flying using FPV requires a high level of focus, as the pilot's attention is directed entirely toward the video feed. This can make it difficult to stay aware of the surrounding environment, especially when flying alone. In some cases, having another person nearby to monitor the surroundings can improve safety. Additionally, FPV drones are generally more difficult to control, particularly for beginners. The first-person perspective can be disorienting at first, and mastering smooth and precise movements often requires practice and experience. How FPV drones are used. FPV drones are versatile and can be used for many of the same applications as traditional drones, including surveying, aerial photography, security operations, and recreational flying. However, they are especially well suited for activities that require speed, agility, and a high level of immersion. One of the most popular uses of FPV drones is drone racing. In this activity, pilots compete against each other by navigating through a course filled with obstacles such as gates, flags, and barriers. The goal is to complete the course in the shortest possible time while maintaining control and avoiding collisions. The immersive nature of FPV flying makes racing particularly exciting, both for pilots and spectators. The live video feed from the drone can be displayed on large screens, allowing audiences to experience the race from the pilot's perspective. Because of the high speeds involved, low transmission latency becomes extremely important, as even small delays can lead to crashes. For this reason, specialized equipment is often used in competitive racing environments to ensure optimal performance. Conclusion. The world of drones is incredibly diverse, and FPV drones represent one of the most exciting and rapidly evolving segments within it. They offer a unique combination of immersion, precision, and creative potential that sets them apart from traditional drone systems. While challenges such as regulatory requirements, technical limitations, and public trust still exist, ongoing advancements in technology continue to push the industry forward. As development progresses, drones are expected to become even more capable and widely integrated into everyday life, providing valuable services across numerous fields. Okay guys, now let's have a little quiz. The quiz consists of 5 questions. I'll give you 10 seconds for each one, and then I'll show you the correct answer. Let's start with the first question. Question 1. What is the main difference between a UAV and a UAS? The correct answer is a UAV refers only to the aircraft, while a UAS includes the aircraft and its supporting components. Question 2. Why are fixed-wing drones generally more energy efficient than rotary-wing drones? The correct answer is they generate lift through aerodynamic forward motion. Question 3. What is the primary function of the onboard camera in FPV drones? The correct answer is to transmit a real-time video feed to the pilot. Question 4. What is a key advantage of hybrid-powered drones? The correct answer is they combine multiple power sources. Question 5. What is one major challenge associated with FPV drone flying? The correct answer is difficulty in maintaining awareness of the surrounding environment. Unlock the world of aerospace engineering with my other expertly designed courses. In aerospace engineering, Basics of Aerodynamics, you'll explore how air interacts with moving aircraft and how aerodynamic forces influence performance, giving you a strong foundation in the principles that enable efficient lift, stability, and control in modern flight. Then, take your knowledge to new heights with aerospace engineering, aerodynamics and structures, where you'll dive into the design and performance of aerospace structures and their aerodynamic behavior. Finally, expand your expertise with aerospace engineering. Rocket Science Basics, where you'll learn about the fundamental principles that govern rocket design, propulsion, and spaceflight, bridging the gap between theoretical physics, engineering structures, and launch systems. Whether you're a student, aspiring engineer, or aviation enthusiast, these courses will equip you with essential knowledge to understand and contribute to the future of aviation. Join hundreds of learners and start building your aerospace journey today. Thank you guys for watching this video. If you have any questions about this lesson, feel free to ask me in the comments section. I will answer as soon as possible. We can continue to the next lesson and learn about camera GPS drones. See you in the next video. Bye.